So up until this point, we have been drawing right angle triangles and setting up our SOHCAHTOA in what I like to call free form. What we're going to do is we are going to take the same concepts, but we are going to actually put that right angle triangle on an XY plane. So let's imagine that we have this gray line and it is our angle in standard position. We're going to draw a right angle triangle with the closest x-axis. So I'm just going to do a dashed line. We have our reference angle, I'll just call that theta prime. So we're looking at a right angle triangle and it is in the third quadrant. Now let's name the sides opposite, adjacent, and hypotenuse. So you'll see those labeled in green. And then if we were going to set up our 6 trig functions, we have sine theta, which is opposite over hypotenuse, cosine theta, adjacent over hypotenuse, tan theta, opposite over adjacent, and all the reciprocals. Now let's imagine that this angle in standard position has an end point, and that end point is on a circle. So I'm going to draw in a circle. So it's getting a little bit busy now, but you see this dashed circle. Trigonometry is based on circles, and we're going to say that this circle is our unit circle, and it has a radius equal to 1. So that means that we have a point right here on the unit circle, and we're just going to call this x and y. Now why that's important is we're going to take our 6 trig functions, and instead of using opposite and hypotenuse and adjacent, we're going to use x, y, and r. So horizontal distance, vertical distance, and radius. So let's go back to the triangle in the third quadrant. Our reference angle, this theta prime, I just highlighted in yellow. The opposite length is really the vertical length. So we're also going to call that the y value. So this length right here. It's a vertical distance, so it's y. So all of our opposites in our equations, we're going to change to be y's. The adjacent of the triangle, I'll do that in blue, is a horizontal distance, which is an x value. So the adjacents are all going to change to be x's. And the hypotenuse is equivalent to the radius of the unit circle. So the hypotenuse is going to change to be r. So now we have a new way of looking at our SOHCAHTOA, and it's by taking the triangle and placing it on an xy plane with a radius of 1. So in this example, I talked about a reference angle. A reference angle is always an acute angle, and it's always attached to the x-axis. So we can have a reference angle in any quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if it's an acute angle, then that means that it's between 0 and 90 degrees. I'm just going to do theta prime. So we could have one in any quadrant. So we're really digging in on terminology today. So the last piece here is quadrantal angles. Those are specifically angles that are found on the XY axis. Here's our XY axis. We have 90 degrees, which is also pi over 2. We have 180 degrees, which is also pi. We have 270 degrees, which is 3 pi over 2. And then we also have 360 degrees, which is 2 pi. So just so it's a little bit less messy, if we have a unit circle, remember, is that the radius is equal to 1. The coordinates of these angles would be 1, 0, 0, 1, -1, 0, and 0, -1. So you really need to be taking some good notes today because I'm going to refer to all of this terminology. One type of question that you're going to have to know how to do is to draw and find a reference angle. So we have the angle that's given to us is 5 pi over 4. So it's in radians. So the first thing I'm going to do is I'm going to draw my XY plane. And we just talked about how this angle here is pi. Now I'm working with radians now because the question was given in radians. If I look at the question that was given to me, it's 5 pi over 4. So what I'm going to do is I'm going to make a common denominator. 4 pi over 4 is the same as pi. The reason why I'm making a common denominator is because I'm trying to figure out where 5 pi over 4 falls. So 5 pi over 4 would fall a little bit further past 4 pi over 4. So it's going to be in the third quadrant. Now how do I find the reference angle? Well, there's a bunch of different ways you can do it. Because I know that the angle is already moving 4 pi over 4, rotating, I should say, 4 pi over 4, how much further is it going to go to end up at 5 pi over 4? So I can make an equation. And I get pi over 4. So my reference angle, which is this angle here, it's an acute angle and it approaches the closest x-axis. This angle is 5 pi over 4.